Creating a knowledge graph using Python and leveraging an NVIDIA GPU can enhance the processing speed, especially if you're dealing with large datasets or complex computations. Here's a general guide to start creating a knowledge graph in Python. We'll focus on utilizing GPU capabilities where applicable. Set up your Python environment. Ensure you have Python installed. You can use environments like Anaconda for easier package management. Install necessary libraries. Pip install NumPy pandas network x matplotlib for basic operations, and pip install cupi cadax. Replace XXX with your CUDA version for GPU accelerated computations with cupi. Data collection and preprocessing. Gather your data. This could be text files, databases, or any other structured, unstructured data source relevant to your knowledge graph. Preprocess the data using Python. If you're working with text data, this might include cleaning, tokenization, and entity recognition. Feature extraction and representation. Extract relevant features from your data. This step is domain specific. For example, in biomedical data, features might be specific medical terms or measurements. Represent these features in a structured format, such as a pandas data frame. For GPU acceleration, consider using cupi, which is similar to NumPy but leverages GPU for computations. Define entities and relationships. Identify key entities in your data. Entities are the primary objects, like nodes in a graph, that your knowledge graph will consist of. Determine the relationships between these entities. These relationships will form the edges in your graph. Build the knowledge graph. Use Network X to create the graph. While Network X itself does not run on a GPU, it's a powerful tool for graph creation and analysis. Alternatively, for large-scale graphs where GPU acceleration is needed, consider using a GPU-accelerated graph library like CUGraph from Rapids. Graph analysis. Analyze the graph for insights. You can use Network X for various analyses like centrality measures, community detection, etc. For GPU-accelerated graph analytics, explore libraries like CUGraph. Visualization. Visualize the graph using Matplotlib or, for interactive visualization, libraries like Plotly or Dash. For large graphs, tools like Gephi or GraphViz can be more effective. Optimization and scaling. If dealing with very large datasets or complex computations, optimize your code to better utilize the GPU. This can include batch processing, parallel computations, and efficient memory management. Iterate and refine. Knowledge graph creation is often an iterative process. Based on your findings, you might need to go back and adjust your entity definitions, relationships, or the structure of the graph itself. Application-specific development. Depending on your final goal, e.g., data analysis, machine learning, decision support, further develop your project to integrate the knowledge graph effectively. Remember, creating a knowledge graph is a complex process that depends heavily on the nature of your data and your specific goals. The use of GPU through libraries like cupi or CUGraph can significantly speed up computations, especially when handling large-scale data. Certainly. To start coding a basic knowledge graph in Python, we'll begin with a simple example. We won't require GPU acceleration for this initial demonstration, as it's a straightforward task. Let's use a small dataset to illustrate how to create a knowledge graph with Python. We'll use the following steps. Install necessary Python libraries. Create a small dataset. Define entities and relationships. Build the knowledge graph using Network X. Visualize the graph. I'll demonstrate the initial setup and the creation of a basic graph. Please make sure you have Python installed on your machine. You can install the necessary libraries using pip. Let's start by coding these steps. Python. Copy code #step 1. Install necessary libraries #. You can install these libraries by running these commands in your terminal or command prompt. #pip install network x matplotlib. #step 2. Importing libraries. Import network x as nx import matplotlib. Pipeplot as plt. #step 3. Creating a small dataset. Let's consider a simple example with a few entities and relationships. Entities equals brain activity, EEG, neurological disorder, patient A, treatment 1, relationships equals brain activity, EEG, neurological disorder, patient A, EEG, patient A, treatment 1. #step 4, building the knowledge graph. G equals NX, graph, G.add underscore nodes underscore from, entities, G.add underscore edges underscore from, relationships. #step 5, visualizing the graph BLT, figure, fig size equals 8, 6. NX. Draw, G, with underscore labels equals true, node underscore color equals light blue, edge underscore color equals gray, node underscore size equals 2000, font underscore size equals 15, PLT, title. In this code, we import Network X for graph operations and Matplotlib for visualization. We define a small set of entities and relationships. We create a graph G, add entities as nodes, and relationships as edges. Finally, we visualize the graph. This is a basic example. In a real-world scenario, the data would be more complex, but you might need additional processing, especially for extracting entities and relationships from your dataset. You can expand on this by incorporating your specific data and more complex relationships. This is a basic example. In a real-world scenario, the data would be more complex, but you might need additional processing, especially for extracting entities and relationships from your dataset. You can expand on this by incorporating your specific data and more complex relationships.
This new domain, there's currently nothing on it. It's called engineer.com. So we will be moving, well, first of all, creating new tools on it, and eventually moving some of the EEG stuff from Biomedical onto it. And Biomedical will be all other stuff, ECG, image processing, etc. And now we want to start with this knowledge graph, which we had ChatGPT making a code for. Kind of works okay. It gives this basic graph. Which looks okay, but it actually gave us more data before. It actually gave us this knowledge graph.
Turning the information about creating and using knowledge graphs for EEG data into a knowledge graph itself involves distilling the key concepts and their interrelationships into a graphical format. Here's a conceptual representation of how this knowledge graph might look.
Yes, we have this more nodes in this one. Patient data relation, pattern analysis, network analysis, predictive modeling, visualization. So that looks better. Just start the folder here. Oh, called EEG. Well, I mean, the website is called the EEG Neo, so everything on it will be EEG related. Let's call it the knowledge graphs. Maybe no space. Right, let's move that into it. Let's have another this will be a text file. And let's pop this in. Have all these child nodes, parent nodes.
Each subnode, like data acquisition and preprocessing, and its child nodes, like EEG data collection and EEG data preprocessing, represent different aspects of the process and are interconnected, showing how one aspect leads to or influences another. For instance, data acquisition and preprocessing would be directly connected to feature extraction and representation, indicating that the preprocessing step is essential before features can be extracted. Creating an actual visual representation of this knowledge graph would involve using a graph visualization tool or software, where each of these nodes and subnodes are visually represented as points or bubbles, and their relationships are lines or arrows connecting them. This visual tool helps in understanding the complex process and interrelations involved in building and using a knowledge graph for EEG data in Python.
We're using network X. Creating node, linking nodes. Yeah, I want to add attributes. So assume the attributes will be, yeah, providing more context. Okay, so let's say this is a data text file. And let's pop this in. Hopefully the bot will already understand the context. We obviously want to change those entities in the Python code. Yeah, so we have the same code using matplotlib to plot and network X to do the structure of the network. Right, so we have main nodes, subnodes, and child nodes. It looks legit. Why is my mouse not working? There's something wrong with the ChatGPT page. Is it going under? Hopefully not just right now. It's obviously eventually will. The problem is, just need the code. Might grab the code and start a new chat, because obviously it's not having a good time. Problems already, and we just started. Okay, let's close this one. Let's make a copy, because that code actually works. Okay, this thing is, the whole page is hallucinating, not just. Let's restart the page. Snap. Big error in Chrome. Okay, did they change the interface again? Yeah, I think that's what happened. They must have, OpenAI must have changed the interface live, because before all the previous stuff was on the side here, now it's top left. So they keep changing stuff, but chat is still there. Okay, so we have main node, subnode, child node, building graph, visualization. Stat size 15. Okay, let's just run this. Should be taking the data text. It's in the same file. What's the problem? A file path, a copy relative path. Oops. Okay, it just should be slash like this. No. That no. What's the problem? Data text is in the same. Okay, let's do the whole path. Okay, now it's running. Couldn't find the file, I don't know why. Okay, so it's scaling quite nicely. The nodes do not move. The page is scaling nicely. The nodes do not move. And also, is it gonna be different when I reload the page? By the way, eventually we want to turn it into a web application available on a website hosted on Apache server. It is a budget server, but no, that's not what I said. I said Apache. Let's close this for a second, just wondering. Copy, can I copy the whole? The whole, no. Control print screen. No, that doesn't work. Let's just run it again, see. Yeah, it looks quite different, isn't it? So we have this graph construction. Graph construction. Yeah, it's always in a different position, but then can reload it from here. Okay, several requirements. Well, I mean, it's okay for them to move, but yeah, maybe they will be loading in the same way, but then you can move them around. Graph layout should be considered each time page is reloaded. Yeah, that's not a bad idea. You want to integrate this knowledge graph into a web application hosted. Yep. Stable node placement. Let's just read this. Can't be bothered reading it.
To ensure the nodes do not move around, you can use a fixed layout for your graph. In Network X, this can be achieved by predefining positions for each node and using those positions every time the graph is drawn. Alternatively, you can use a layout algorithm that provides stable positions across different runs, such as the spring underscore layout with a fixed random seed.
Let's just be back inside. I'll just let it read it. I'm still listening to it. Got my Bluetooth headphones. They still work, so I'm not going over 10 meters away.
2. Consistent layout across reloads. Use a deterministic layout algorithm or a fixed layout, as mentioned above. By setting a fixed random seed, you can ensure that the spring underscore layout, or similar algorithms, generates the same layout each time. Save the positions of the nodes in a file or database, and load these positions every time the graph is rendered. 3. Web application integration. To turn the knowledge graph into a web application, you will need to use a web framework. Since you're working with Python, Flask or Django could be good options. The graph can be rendered on the client side using JavaScript libraries like D3, JS, which offer great flexibility and interactivity for graph visualization. For hosting on an Apache server, ensure your web application is packaged correctly, e.g., using a WSGI file for Flask apps, and configure Apache to serve your application. Example integration steps. Backend, Python plus Flask, Django. Your Python code handles data processing and graph construction. The backend can serve JSON data representing the graph structure to the front end. Front end, JavaScript plus D3, JS. Use D3, JS or similar libraries to draw the graph based on the data received from the backend. D3, JS provides functions to create a static layout that remains consistent across reloads. Hosting on Apache. Deploy your Flask, Django app on the Apache server. Configure Apache with mod underscore WSGI for Flask, Django apps, and serve your web application. Development and testing. Develop the application locally, test the functionalities, and ensure the graph behaves as expected. Once everything is functioning properly, deploy the application to your Apache server. This approach combines Python's data processing capabilities with the interactive and dynamic features of JavaScript for web visualization, providing a robust solution for your web-based knowledge graph application.
Okay. Yeah, we know all that. We're already hosting a bunch of yes, we're already hosting another website on this Apache server with multiple Flask applications. So this one will be an additional one. So we'll implement it in the same way. Regards the knowledge graph itself, can we improve on it? Any suggestions? Specifically thinking, yes, loading it in the same, exactly the same way every time the page is loaded, and then allowing moving the nodes around as per user request. Also, color can be improved. Yep.
Given that you're already hosting multiple Flask applications on your Apache server and are familiar with the setup, adding another Flask app for the knowledge graph should be straightforward. Let's focus on improving the knowledge graph's interactivity and consistency across page loads. To ensure that the graph loads in exactly the same way every time, you can use a deterministic layout algorithm. Here's how you can achieve this. Fixed layout. Define fixed positions for each node in your graph and use these positions every time the graph is rendered. This approach requires you to pre-calculate and store these positions. Deterministic algorithm. Use a layout algorithm with a fixed seed. For instance, in Networks' Spring_layout, you can set a random seed to ensure consistent results. For interactive manipulation of the graph, like moving nodes around, consider using JavaScript libraries like D3.js. D3.js allows users to interact with elements of the graph directly in the browser. Draggable nodes. Implement draggable nodes in D3.js. This feature lets users click and drag nodes to different positions on the screen. State persistence. To remember the node positions as adjusted by the user, you can store these positions in the browser's local storage or send them back to the server to be saved. Improving the color scheme and overall aesthetics can make the graph more user-friendly and visually appealing. Color coding. Use different colors to represent different types of nodes or relationships. This can improve readability and help users quickly identify key parts of the graph. Styling. Apply custom styles to nodes, edges, and labels to improve readability and visual appeal. For instance, larger nodes for more important entities, varying edge thickness based on relationship strength, etc. Tooltips and interaction. Implement tooltips that show additional information when hovering over nodes or edges. Interactive elements like clickable nodes can enhance user engagement. Since you're familiar with Flask, here's a basic outline of how you can structure the application. Backend, Flask. The Flask app serves the initial HTML page and provides endpoints to fetch graph data in JSON format. Frontend, D3.js. Use D3.js to render the graph in the browser, based on the data from Flask. Implement interactive features like draggable nodes and tooltips. Data persistence. If the user modifies the graph layout, send the new positions to the Flask backend to save them. This can be done via AJAX calls. This example is a starting point for draggable nodes in D3.js. You would need to expand this to include saving positions and possibly loading initial positions from the server. Integrating these features will create a more dynamic, user-friendly, and visually appealing knowledge graph, enhancing user engagement and making the data more accessible and understandable.
Let's get back to it. There's a JavaScript, Spring layout, seed 42. How does that work? Why do I set a random set to get consistent result? Anything random sets would not yield consistent results, but what do I know? just do something quickly. Doesn't happen often, but we had to remove a user. Sorry for that. Okay, so I have a JavaScript file. The question is, how do I link them all together? So I have a Flask backend, a JavaScript frontend. We have the data file.
This example is a starting point for draggable nodes in D3.js. You will need to expand this to include saving positions and possibly loading initial positions from a server. Integrating these features will create a more dynamic, user-friendly, and visually appealing knowledge graph, enhancing user engagement and making the data more accessible and understandable.
Yes, save that. We have the data file that has all these nodes. Will be the front page of engineer.com, a new website. Question is, don't have positions at the moment, do we? No, we do. We're already using a Spring layout. We just add fixed seed. Comment that out. Okay, we need to continue. Turn this into a Flask application first. Okay, more information on this. Okay, the website. I think it's again OpenAI website is stuck. Can't scroll through it. It will now, yeah, give me Didn't used to get this error messages before. This is a new one. Let's wait a couple times, see if anything is happening. Yeah, Chrome is currently using like 5% of my CPU, which is quite a lot, considering it doesn't actually do anything at the moment. Okay, is the website back? No, it's not back. Is that to restart it? I think the OpenAI making some changes to the chat page. So this is happening real time. I don't know, maybe the pages are just for me. Snap. Yeah, I don't want to learn more. This scary. Yeah, I don't know what they changed. Doesn't seem like major change, but yeah, the response is still there.
To implement the backend for your knowledge graph using Flask, you'll create a Flask application that serves an HTML page and provides endpoints to fetch and update graph data in JSON format. Here's a basic structure of how you can set this up.
Yeah, we have done this multiple times before, haven't we? So we should know how to do it. Should be a templates folder, a static folder, and then app by file. Dummy data for the knowledge graph. Now our question is if we should turn the data text file into a JSON file. Let's copy this for now.
In this script, the index route serves the main HTML page, and the graph data route provides the graph data in JSON format. Create a file named index.html inside the templates directory. This HTML file will include the structure of your page and references to any JavaScript or CSS files you'll use for rendering the graph.
That is not called GraphJS, it's called T3JS. Probably GraphJS is a better name.
Place your JavaScript, D3, JS code for the graph, and CSS files in a static directory. For example, the D3, JS script that renders the graph could be placed in static/js/graph.js.
Okay, so this goes in the static directory and should be rename it into GraphJS. Can run it from here. We have the link for it. And it doesn't show anything. Okay, why not?
This setup provides a basic structure. You need to expand on this, particularly in static/js/graph.js, where you'll implement the D3 JS logic to fetch the graph data from the Flask endpoint and render the graph interactively. Also, consider adding AJAX calls to save any changes made by users, like node positions.
Okay, hi Rohan. Have to remember to, I need some sort of stop sign, so when I'm editing the video, if I eventually decide to include this in a standalone video, I have to remember to edit this bit out. What's the question? Please make one project on sign recognition. So the sign recognition, we already started on it. This is where this face, this mesh and hands come from. This was a while back. Now the reason this is not on the website on Biomedical is because it was, why is my mouth? No, my mouth is moving. Okay, kind of. I think it's if it's too dark in the room. The hands are much better. I think it's like the way my mouth is facing to the camera. Because another thing you could do like lip reading recognition and stuff. But yes, you're asking specifically about sign recognition. So we already had it. There is a big project, I'm sure, that you already have seen. It's on kaggle.com. Should have a section on Biomedical about it. I'm not sure if I actually published it or not, but there will be all the information there. But yeah, if you go and look up a Kaggle competition, there should be all there, and then they're using the same media pipe, the same thing that I'm using for the face recognition, and taking snippets of hand motions and translating them into text. And yes, I would like to follow up on that, but then maybe you can do it. Because I was using that data for the competition before the competition have ended. So supposedly now you will have this winning algorithm for it. So I wonder how well it's performing. But again, maybe you could have a look. Let me know if it's worth another. Yeah, I'm happy to spend a couple of live streams on it again. Pretty sure we had a section on. There will be all the live streams that where I was doing it, that they should be available. But yeah, where is it? It's not EG, Cochlea. Yeah, obviously most of the stuff is on EEG, but I have this new domain that most of the EEG stuff will be moving on to eegnear.com. So So Biomedical will be mainly, yeah, all this other stuff, ECG, image processing, speech recognition, and yeah, hopefully. The other problem was privacy issues. So for the web application to work, you need to allow a camera, your webcam, to be displayed on the website. That's another thing I didn't want to go into because you're getting into all sorts of privacy issues, even though that footage is not uploaded to the server. So yeah, if it's not uploaded to the server, then I essentially cannot use the fancy processing for the hand gesture. So everything will have to be happening in your browser. And I think that's where the problem is. Those algorithms are too heavy to do so. But again, there were quite a few advancements in it. So you probably should look at it again. Yeah, I can't even find it, but yeah, maybe you can have a look at it again. It's on Kaggle. Should be a link and everything. How to spell Kaggle? Kaggle.com. Ah, that's the seizure prediction. Seizure. Yeah, I was doing the seizure prediction competition. Yeah, the hand recognition is not mentioned, but it's a big competition. It comes up on Kaggle straight away. Let's just quickly go back to the knowledge graph. It's quite important. If there are no other questions, get back to the knowledge graph. Hopefully we can show something useful. Let's see if it has any, it's giving any errors. Probably does. No, it does not. It's actually worse that it doesn't. No errors, but it's not showing anything. It's not showing anything. Yeah, there's some sort of integration thing.
If your Flask application running at http://127.0.0.1:5000/is not showing anything, there are several steps you can take to troubleshoot and resolve the issue. Ensure your Flask application is running without errors. When you run app.py, look for any error messages in the console. Make sure you're running the Flask app in a Python environment where Flask is installed. Confirm that the index root in app.py is correctly defined and pointing to the right template. Python copy code at app.root. Def index. Return render_template, index, HTML. Check that the index, HTML file exists in the templates directory. Ensure that any static files, JavaScript, CSS, referenced in index, HTML exist in the static directory and are correctly linked. Open index, HTML and ensure it contains the correct HTML content. If you're using JavaScript to render content dynamically, e.g., with D3.js, ensure that the JavaScript code is error-free and properly connected to your Flask backend. Open the page in a web browser, right-click, and choose Inspect or Inspect Element to open the developer tools. Check the console tab for any JavaScript errors or network errors. This can give clues if there's an issue with fetching data from the Flask server or with the JavaScript code. In the developer tools, check the network tab to see if the request to http://127.0.0.1:5000/ is successful and if any resources, like JavaScript or CSS files, fail to load. Ensure that no firewall or network settings are blocking your access to http://127.0.0.1:5000/. As a test, modify index HTML to include some simple static content.
Yes, we know the problem is the JS wasn't referenced correctly. It's actually in a different folder, but now it's also giving an error. Right, we need to load this D3.js to include it in our HTML. Okay, so this is some sort of CDN to check that that link is actually working. Okay, it is working. Copyright 2021. Is another error. By the way, another thing that I need to edit out that I'm about to say. This person who commented before with swearing, using some strong language about AI, whatever. I don't know why it's targeted at me. I'm actually trying to explain AI, trying to make it more accessible for everyone and try to explain what is it actually doing, how to use it, how to develop it, so on and so forth. So, well, first of all, any comments with F words and the like will be deleted and the person will be blocked, which I did. But then, yeah, maybe just learn about it some more, see what's what. It is here to stay, so might as well, at least try and understand what it's all about. No one is taking over or, things like that. So I don't know what movies you watched, but yeah, so just back to reality. Trying to troubleshoot this thing. What we generally trying to do is pretty straightforward, pretty simple. Trying to show a graph that actually explains that explains EEG data processing. So it's called a knowledge graph. It's quite useful. We'll eventually make it accessible for everyone to see and use and look. Hopefully you will be able to move these nodes around or expand on certain sections. But yeah, this is what the generally EEG data involves, is analysis, data acquisition, challenges, feature extraction, visualization, machine learning integration. So you have this. Yeah, so hopefully we will improve on this graph and make it more interactive. So you start with a few nodes, like, well, maybe like this, and then you can expand on some of these sections, and so it helps you learn about EEG processing. And this hopefully eventually will be on eegeneer.com, hopefully today or later this week. And yes, some of the stuff, EEG stuff from biomedical.com will move across as well. So, just as a more organized should be a more organized website, so not as chaotic as Bionic Chaos. We're still having some problems with this. We actually need to run this app, so we're doing a Flask application. This one should be fairly straightforward, and we don't see anything why. We can try to call this GraphJS from JS folder. We don't actually have JS folder. So where is it being? Let's search for it quickly. JS folder. Right, we have it over there. I thought we changed that. Okay, nodes are not defined in GraphJS. Could not find name nodes. This should be a node. This is from a GitHub Copilot. Do Control I. No, actually, a Copilot fix this. Did it fix anything? Just change it from nodes to node. Okay. So node actually is there. That means GPT4 was wrong. Can we ask to let's confirm this in our Python code. We have rendered template, that's right, and show the template static files. Index.html is in folder called templates. Okay, the other thing is where is it taking the data from? So I have a data in the text file. Let's copy this again. This is a data file. This probably should be translated into a different format, like JSON, probably be ideal. We can try it later. Yeah, we need to pass this file, that's correct. We already did this before. Okay, how about we stop this? Yeah, that page. Yeah, something is happening at OpenAI again. It's the CEO back, and while the CEO was away, they managed to break the site. Yeah, it keeps crashing. I also have a feeling it might be using this add-on for extension for ChatGPT voice control thing. Maybe we turn it off. See, because that's changing the page. Maybe that's where the problem was coming from. Let's actually finish the code. We might as well use it. Let's read this
To
quickly.
create a knowledge graph from the structure provided in your data.txt file, you will need to parse the file and then use the parsed data to construct the graph. The structure of your file suggests a hierarchical organization, with main nodes, subnodes, and child nodes.
Right, that's correct.
You need to write a Python script to parse data.txt. The script should recognize main nodes, subnodes, and child nodes, and then store these in a structured format, like a dictionary or a list of tuples.
Okay, so it's not suggesting a JSON file, it's suggesting going straight for dictionary or tuples.
After parsing the data, use a Python library such as NetworkX to create the graph. You will create nodes for each entity, main node, subnode, and child node, and edges that represent their relationships. Once the graph is constructed, you can visualize it using libraries like Matplotlib or, for more complex visualizations, GraphViz.
Yeah, we're using... what are we using? Well, wait a second. Now we should be using JavaScript, HTML to plot. This one's using Matplotlib. That's not the Flask application. It's what we already had. Okay, we're getting stuck here. So we need to turn this into a web application. Just do full path for now, so it works. Okay. So how do I integrate this with the Flask application?
Integrating a knowledge graph generation script with a Flask application involves a few steps. Essentially, you'll have the Flask app service the backend, which will handle requests to generate and return the knowledge graph data. This data can then be used by the front end, likely in JavaScript with a library like D3, JS, to visualize the graph. Here's a high-level overview of that.
You're going in circles. It's as if it forgot the context of what it generated prior.
Implement a Flask route that, when accessed, runs the knowledge graph generation script and returns the graph data in a JSON format. This is the data that your front end will use to render the graph. On the front end, use JavaScript to fetch the graph data from your Flask backend and visualize it. You can use D3, JS, or any other suitable library for this purpose.
Give me dummy stuff again. Yeah, this function. So should that point to the other Python code? Save that for a sec. HTML. Have console log. And this HTML doesn't work as it is, so might as well.
In this example, the Flask app serves an HTML page that makes a request to get graph data to fetch the graph data. The data is then logged to the console, but in a real application, you would use D3, JS, or a similar library to visualize this data. Remember, this is a basic example. You need to adapt and expand it to suit your specific needs, especially the generate_graph_data function in app.py and the JavaScript for rendering the graph in index.html.
You to do it. Well, first of all, because we already have the code for it.
To integrate the function that generates graph data into your Flask application, you need to replace the placeholder generate_graph_data function with your actual function that processes the data.txt file and creates the knowledge graph data structure. Assuming you have a function that reads the data.txt file, passes it, and returns a structured representation of your knowledge graph, as shown in previous examples, you can integrate it into your Flask application as follows. First, define the function that generates the graph data. This function should read and parse the data.txt file and then transform it into a JSON-like structure, a dictionary in Python, that can be easily converted to JSON for front-end. In your Flask application, app.py, replace the placeholder generate_graph_data call with the actual function. In your index, HTML, use JavaScript and a library like D3.js to visualize the graph. The graph data will be fetched from the getGraphData endpoint of your Flask application.
So I already have that. What about the JavaScript?
With this setup, when you access your Flask application, it will serve the HTML page that, in turn, requests the graph data from the Flask backend. This data is then used to render the knowledge graph using D3.js on the front end.
Back again. Just wait once and restart the page. I don't know what's up. Yeah, the OpenAI site is stuck. Again, it's like the 4th time today. Probably should start a new chat because this one keep hallucinating because we restarted it several times. So far so good.
Chat GPT. To use the parse_file function within your Flask application, you need to define it in your Flask apps code. This function is responsible for reading the data.txt file and parsing it to extract the graph structure, which will be used to generate the graph data. Let's define the parse_file function based on the structure you provided in your data.txt file.
Yeah, let's just go with this for now. I won't be able to do anything better myself. Anyhow.
Now, integrate this function into your Flask application, app.py. Include the parse_file function and the generate_graph_data function that uses it.
I think we're already doing that. Okay, we're not getting any errors. Don't see the graph. But that error is okay. It's just can sort that one later. Get graph data. Let's see if this works. Okay, it does. Have the nodes and everything. Works. So, yay. But do we have another get graph data? But I don't see anything displayed on the page. T3.js is properly loaded in HTML. It's running before any other script.
The JavaScript code that handles the graph rendering is crucial.
Yeah,
Make sure the script in index HTML is correctly fetching the graph data and using D3.js to render it. If you haven't added the D3.js rendering logic yet, this is the place to do it.
Right, well, didn't have it. So this is all okay. Why don't we have a separate GraphJS? Okay, so we wanna update the graph.js. Move all the JS code into graph.js and update HTML. Yeah, we have a graph.js. It's never actually working. Okay, so generating a graph. Fetch graph data. Render graph. This is graph.js. In HTML. Don't need this script anymore. We're linking to graph.js. It's in a static folder. See if this still works. Yes. Right. See something. It's jumping around. They're always the same here. Can't move them. There's no lines. There's no text. That's a good start. Considering this is our first knowledge graph, it's not too bad. The graph is loading now, but it doesn't have any text. I cannot move the nodes. So how to improve this? Yep.
Great to hear that the graph is loading now. To enhance the graph with text labels and interactive features like movable nodes, you can extend your D3 JS code in graph.js. Let's go through these improvements step by step. To add text labels to each node, you'll need to append text elements to your nodes in D3.js. Here's how you can do it. Modify node data. If your nodes don't already have a label property, modify your data to include a label for each node. For simplicity, I'll assume that the node's id is used as its label. Append text elements. After creating the circles for the nodes, append text elements to each node. To make nodes movable, you need to implement a drag behavior in D3.js. Here's how you can do it. Define drag behavior. Create a function that defines what happens when you drag a node. Apply drag behavior to nodes. Apply this behavior to each node in your graph. In this code, the drag started, dragged, and drag ended functions define what happens when a node is clicked and dragged. The drag behavior is then applied to each node using node call drag. You might need to adjust styles, like the text font size or the node size, for better visibility and usability. Ensure that the simulation's tick function updates both the node positions and the text positions. With these changes, your graph should now display text labels for each node and allow users to click and drag nodes around. This will significantly improve the interactivity and usability of your knowledge graph visualization.
Yeah, do we have time? Pretty much have this one function in JavaScript. We have the node circles as well, don't we? So we're changing that. Okay, how do I integrate properly? Now we have nodes, and this one is node and singular. Here I have existing code.
To make nodes movable, you need to implement a drag behavior in D3.js. Here's how you can do it.
Still in render graph.
In this code, the drag started, dragged, and drag ended functions define what happens when a node is clicked and dragged. The drag behavior is then applied to each node using node call drag. In this code, the drag started, dragged, and drag ended functions define what happens when a node is clicked and dragged. The drag behavior is then applied to each node using node, call, drag. You might need to adjust styles, like the text font size or the node size, for better visibility and usability. Ensure that the simulation's tick function updates both the node positions and the text positions.
Is this correct code? I get the text labels separately to the nodes themselves. And the nodes are not movable. Yep.
It looks like there are a couple of issues in your code that need addressing. Duplicate node creation. You have two blocks of code creating nodes, one creating circles and another creating a group G with circles and text. This duplication likely causes the labels to appear separately from the nodes. Applying drag behavior. The drag behavior needs to be applied to the node groups, G elements, rather than the individual circles to ensure both the circle and its label move together. Let's refactor your code to address these issues. This code creates a group, G element, for each node and appends a circle and a text element to each group. The drag behavior is applied to these groups, allowing both the circle and the text label to be dragged together. The tick function of the simulation now updates the position of the entire group, which moves both the circle and its label.
Okay, so it does kind of work. Okay, we could rewrite the data. Okay, this is working much better. I can move nodes around. There are two problems. One is that there are no lines between the nodes. And the second problem is that the text is too long and overlaps on top of one another between the different nodes. Yep.
Great to hear that your graph is now interactive. Let's address the two issues you're facing. If the lines, links, between the nodes are not showing, it might be due to missing or incorrect attributes for the lines. Ensure that the link data is correctly bound and the line attributes are set appropriately. In this snippet, ensure you're setting the stroke color and width for the lines. Adjust these attributes as needed for your graph. If the text labels are too long and overlap, you can truncate the text if it's too long. Adjust the text positioning or add a text background to make it more readable. Implement collision avoidance or forced layout adjustments to keep labels from overlapping. Here's a simple way to truncate text if it's too long. This will shorten any label with more than 10 characters and append to indicate truncation. You can also improve readability by adjusting the font size or adding a background to each label. This code adds a white rectangle behind each label to improve contrast and readability. For more advanced label placement and collision avoidance, you might need to implement additional algorithms or use a D3.js plugin designed for this purpose. However, the solutions above should help improve the immediate issues with your graph.
Yes, first of all, regarding the lines, I already have the links. A constant. So I guess we have to update that.
In this snippet, ensure you're setting the stroke color and width for lines. Adjust these attributes as needed for your graph.
Right. Yeah, ideally they will not overlap to begin with.
If the text labels are too long and overlap, you can truncate the text if it's too long.
We already have append text. Yes, we do. Right, this is better.
This will shorten any label with more than 10 characters and append to indicate truncation. You can also improve readability by adjusting the font size or adding a background to each label.
We already have this bit now. This will only complicate things, wouldn't it? It's too small as a yeah, like it, but let's just try it out. before the text, is it? So order, and that does matter.
For more advanced label placement and collision avoidance, you might need to implement additional algorithms or use a D3 JS plugin designed for this purpose. However, the solutions above should help improve the immediate issues with your graph.
It's the collision avoidance. Yeah, I want to spread them out some more.
Implementing collision avoidance or forced layout adjustments in
Sorry.
Implementing collision avoidance or forced layout adjustments in D3 JS can be quite complex, as it involves dynamically adjusting the positions of text labels based on their size and the positions of other elements in the graph. D3 JS doesn't provide a built-in solution for label collision avoidance, but you can implement a basic version yourself or use a third-party library.
Yeah, this looks like it's implementing one.
A simple approach is to adjust the positions of the labels after they have been placed, moving them slightly if they overlap with others. Here's a basic example. In this function, nodes would be an array of your graph nodes with their x, y, and radius properties. Call this function in your simulation's tick event to adjust the positions.
This just works as a function as a pass the code. Given an error, actually running.
For more sophisticated collision avoidance, consider these approaches. D3 Label Plugin. This plugin uses a simulated annealing algorithm to minimize label overlap. It's a more advanced solution, but might require significant integration effort. Force-directed layout adjustments. Adjust your force simulation to take into account label dimensions. This approach might involve creating invisible nodes for labels and defining forces to keep them away from other nodes. Quad tree-based collision detection. Implement collision detection using D3's quad tree. This is a more complex approach and requires a good understanding of D3 and spatial indexing. Limitations. Collision avoidance can be computationally expensive, especially for large graphs. Fully preventing overlap in a dense graph might not be feasible. Sometimes, simplifying the graph or providing interactive features like zooming and panning can be more effective. These are starting points for implementing label collision avoidance. Depending on the complexity of your graph and performance requirements, you might need to experiment with different approaches to find what works best for your specific case. Radius property. The avoid label collisions function assumes that nodes have a radius property, which isn't defined in your current setup. You need to either calculate or define this radius based on your node size. Node update in simulation. The avoid label collisions function updates the positions of the nodes to avoid collisions, but these updates might be overridden by the simulation stick function. Complexity and efficiency. The current approach is a simple brute force method and may not be efficient or effective for complex graphs. It might require a more sophisticated algorithm for better results, especially for dense graphs. Define and use node radius. You can add a radius property to each node, either as a constant or based on some attribute of your data. In the render graph function, when you're setting up the nodes, modify the avoid label collisions function to be more efficient and effective. Here's a revised version. This function iterates through each pair of nodes and adjusts their positions if they overlap. Ensure that the avoid label collisions function is called within the tick function of the simulation. This will repeatedly adjust the node positions during the simulation. Performance. For large graphs, this collision avoidance method may be computationally expensive. Consider optimizing it or using a more sophisticated algorithm for complex graphs. Dynamic layout. Keep in mind that collision avoidance in dynamic, force-directed layouts can be challenging due to the constantly changing positions of nodes. This solution should help improve the collision avoidance in your graph, but fine-tuning might be necessary based on the specific characteristics of your data and the desired behavior of the visualization.
Okay, so we place the output image HTML Flask application front panel directly into GPT4. Let's see what it says.
The overlap in your graph labels indicates that the collision avoidance code isn't effectively separating the labels. This can happen due to several reasons, such as the force simulation overriding the manual position adjustments, or the collision detection not accounting for text size. D3, JSV4 and above include a force collide which can be used to prevent elements from overlapping. You can add it to your simulation like so. This will add a collision force that prevents nodes from overlapping based on their radius and the specified padding.
Before it said that the D3 does not have collision avoidance. Now it says it does. But don't have the padding. Let's work. this padding be added to the data? Why is it not staying where it is? Anyway, we need to make those adaptive somehow depending on the screen size. Yeah, so it's loading always in the same way, which is good. I have the data acquisition. Anyway, it's looking good so far. Yeah, been 2 hours on this. It's kind of a nice result. Yeah, we need to do more with the size of this knowledge graph. Yeah, it's kind of still, it's just weird. server action bit. The other stuff keeps moving. Right, let's stop moving. Still some major overlap. I don't know why it even lets me select the text. Yeah, there's a lot of improvement that can be done, but it's a good start. So see